Okay, now let us talk about a very simple looking but extremely complicated inside generic classifier application. This would be a nice example for displaying to a client what exactly data scientists do. So let us first upload the data file. Let us first take iris data file, and this is that data. Now as soon as the data is uploaded, first of all in the upper window, some statistical summary is displayed, which is here I have grayed out in that window. Okay, so you can see that how many columns are there, how many non-null values are there, and what is the data type of each column. So there are 150 entries, and all 150 are non-null. So this is a simple data set in which there is no null value. However, even if there are some null values, you can always do some treatment. Now, these columns are sepal length, sepal width, petal length, and petal width. These are four characteristics or features of plants. And once this data is given, these four columns are given, you are supposed to predict this species. That is the fifth feature. Remember, it starts from zero. Okay, so four written, that is actually fifth feature. Or it is not a feature, but it is an outcome variable. So species you have to predict based on what is the sepal length, sepal width, length, petal width, and species can be either Setosa, Virginica, or versicolor. Now, as such, this is a very well-known data set, and some people may think that this is a very simplified example he is taking, but I will show you the complexity of this app is not in the data set, it is in the versatility of how this app makes it easy to apply different algorithms quickly with different hyperparameters, and how it produces results in a comparable manner so that you can easily choose which algorithm is giving the best result, and how it plots different types of plot, ROC curve and precision recall curve and PCA explained variance and PCA 2D projection, and so many for each algorithm and for each selection of hyperparameter. So this is a very versatile app. Let us first put target variable. Target variable means what you are trying to predict. So as I said, I am trying to predict the species using this sepal length, sepal width, petal length, and petal width. Okay. Now, this is the random forest algorithm which I am choosing. As soon as I choose that algorithm, you can immediately see that some important hyperparameters of that algorithm, which are normally used for tuning that algorithm, that are populated on the user interface. So, n estimators, number of estimators, maximum depth. Random forest is a ensemble model of tree. So how long you want to grow their tree, how deep you want to grow actually, minimum sample split, minimum sample leaf, etc. So I am choosing the default values and I am clicking retrain and evaluate. Within a fraction of second, it gives me accuracy 100% accuracy, precision also 100%, recall also 100%, and F1 score also 100%. Now that is because this iris data set is such that it yields it very nicely to the classification, and the features are such that the three species Setosa, virginica, and versicolor, they are very easily distinguishable. But in practical data set, this is not the case. Then why I have started with this example? The reason is that this is a multi-class classifier. There are no two classes but three classes: Setosa, Virginica, and versicolor. Okay, and this generic classifier can handle binary classification, two classes, or it can also handle multi-class classification, multiple classes. So that is what I wanted to show. Okay, this is the results, statistical results, and now let us plot some curve. So ROC curve. Now this dotted black line, that we all know that that is the coin toss accuracy, 50-50%, and these red line, that is the ROC curve of our model, and obviously it is the ideal model with 100% accuracy. So you get ideal ROC curve. For practical models, we will take another example of a practical data set. It will not be that. Now below the ROC curve, a helpful hint is also provided, that what ROC curve shows. This plot shows the performance of the classification model at various classification thresholds, and the area under the curve can be used as the summary. And here for all classes, class 0, 1, 2, Setosa, Virginica, versicolor, the area is 100% area is covered. So that means for all classes, this is the best classifier, this random forest. Remember, even though this is a simple data set, it is not necessary that for this data set all classifiers will give 100% accuracy. Actually, random forest and XGBoost, they are two very powerful classifiers, so they give 100% accuracy, but not all classifiers. Okay. Now something more. Let us take another curve. So this time I plot precision recall curve. Even that also shows that precision recall curve covers one area, that is 100 area. What shows? It shows the trade-off between high precision and high recall. The area under the curve represents expected precision at a given recall rate. Okay, high area suggests, let me magnify this slightly. High area suggests high precision and high recall, and here also area is 100%. So that means it is clear that this is a good model. Then let me check PCA explained variance. Now you can see here it is number of components and explained variance. Number of components means the features actually. So it is kind of a representation of features. So you can say that if you take no feature, then obviously your variance explained will be less. Then compared to that, if you take one feature, then explained variance will be less. If you take three features, actually 0 to 3, that means four features. That is, if you consider all columns, sepal length, sepal width, petal length, petal width, you do not remove any column, then you get 100% explained variance. So this model again explains 100% of the variance in our data set. Okay. Now 2D projection. Okay. And here you can see there are some null values, but our this what you say, actually the generic classifier has been made robust to, no, these are not null values, I'm sorry. These are three classes actually: 0, 1, and 2, Setosa, Virginica, and versicolor. And you can see that you can easily distinguish between the classes by drawing classification boundary. That I can draw one classification boundary like this, so green would be separated. I can draw another classification boundary, maybe somewhat like this. Then red would be separated, and blue. Only one red dot is creating some problem, but that is okay. Now, then I can draw cumulative gains curve. Now here you can see slightly that even 100% accurate model is not the best model. Actually, cumulative gains or AUC for cumulative gains is here 0.58, but that is the best possible which we can do. Okay, and then there is this calibration plot, sorry, lift curve. So lift curve for class 0 is shown by blue color, lift curve for class 1 is shown by orange color, that overlaps I think, and lift curve for class 2 is shown by green color. And all lift curve have showing good lift. What does lift curve show? That also I have here provided. That show how better the classifier performs at various thresholds compared to randomly guessing for that particular class. And blue color is somewhere having less lift. So that means the classifier performs well for maybe green and orange classes. That is class 1 and 2 compared to class 0 blue color for different thresholds. Okay, then I close this and silhouette analysis. Now that you can see again that if I take number, how many clusters should form. So ideally this is a three class classification. So as I showed on that map, that three classes, three dots should be separated easily. So here two clusters if I take, then around 0.75 silhouette score. So obviously if I extend this and somewhere here and start this scale from three clusters, then I can even reach maybe 100% silhouette score or something like that. Okay, one plot which was left was I think calibration plot. Yes, so calibration plot also shows again that 100% accuracy does not mean that this model will perfectly predict the class for all three classes. What does calibration plot compare? It shows compares predicted probability with actual outcomes. A well-calibrated model will have probability which may match the actual likelihood of event. Now, where is that actual likelihood? That is this perfectly calibrated red color dotted. Here it is like this perfectly calibrated curve. So, if your curve matches that perfectly calibrated curve, and here it is matching for blue, I think, but for orange and green, it is slightly offset. So that shows that maybe for classifying Setosa class, this model will work perfectly, but for classifying versicolor and virginica here and there, it may make some small mistake. That is possible. Okay, so that is fine. Now I have shown all curves for this random forest model. Same thing I don't want to repeat for all models, but I just want to show that this how this app is so powerful. So now I can choose SVC, support vector classifier, and I just again place train and evaluate. So my random forest models results are maintained, and below which SVC results are maintained, support vector classifier. It also gives 100% accuracy, precision, recall. Fine. Now, and again I can plot this. I am just showing one curve, ROC curve, and this is ROC curve is perfect. I can plot all other curves also for this classifier, but then KNN classifier I am using, and I again write train and evaluate. Now the results of random forest is maintained, result of SVC is maintained, and this is the result of KNN classifier. Again accuracy is 1 and so on. So this time also I can plot, say this time I plot a different plot, 2D projection, PCA 2D projection plot. Okay. Now remember, I am not even showing how you can vary the hyperparameters. So this app can be a good even teaching tool to teach effect of changing hyperparameters. Okay, I will show in one example at least. XGBoost now. Again, I am keeping the default hyperparameters and I am just clicking train and evaluate. XGBoost is also extremely powerful model. So So it also gives a 100% accuracy. This time I plot maybe calibration plot, and you can see that that gap between ideal red dotted curve and green and orange has decreased slightly. Okay, then maybe okay, XGBoost, AdaBoost, then again train and evaluate. You can see all previous results are maintained. So one can easily compare various algorithms and choose the best possible for given data set. Okay. Now this AdaBoost is there. So it also gives 100% accuracy. In AdaBoost, there are two algorithms, SEMI and SEMI.R. This is the variation of learning rate. As it is already 100% here, there is not much point in changing hyperparameters. So I will show it in other example. Hist gradient boosting. Hist gradient boosting is the latest addition in sklearn. It is robust to the null values, so I have included that also. It also again gives one eta boost. This is okay. I have not clicked train and hist gradient boosting and one. So again 100% all parameters, and this time I plot maybe lift curve, and you can get the lift for various classes. Okay. Now similarly, I just want to show that even for ideal data set like IRIS, it is not accuracy that is 100% always possible. Logistic regression gives 100% accuracy. Then a decision tree, that will also give 100% accuracy. Then gradient boosting, that will obviously give, it is a powerful algorithm. Light GBM, that will also give, this is for gradient boosting. I think I have not train and evaluate button is not clicked, but yeah, gradient boosting. Then light GBM, which is also light gradient boosting model, and it also gives quite 100% accuracy. Then maybe Gaussian naive Bayes. Here you will perhaps see that you will not get 100%. Yes, it is around 97% accuracy. So it is possible even for 100% accurate model to give maybe one or two classes here and there which are wrong. One observation is here misclassified. That is clear. Okay, and you can see the ROC curve also. Then it looks almost ideal, but it is not perfect. And you can see cumulative gains curve, that gives more clear idea that this is not 100% accurate model. So even a very cooperative data set which yields itself easily to the classification is not necessarily will give 100% accuracy for all. That gives the that shows the importance of choosing the right algorithm for right data. I choose Bernoulli naive Bayes. Actually, Bernoulli naive Bayes and all these are for discrete data set. So it is producing somewhere. But you can see class 1 recall and class 0 recall and F1 score for class 1, and compared to maybe here if you see, this was earlier, most earliest XGBoost or random forest, everything is 100%. Okay, so precision for class 0 100%, precision recall for class 0 100%, F1 score 100%, class 1 again 100%, and class 2, that is Setosa virginica versicolor, all is 100%, while this is not the case here. You can see that precision and recall are very poor compared to those models. So obviously, because Bernoulli naive Bayes is not meant for actually this kind of data set, but I have included it because this is a generic classifier, so there may come another data set which requires Bernoulli naive Bayes. Now this is a neural network in which activation function can be ReLU, 10H logistic regression, in which solver can be Adam, stochastic gradient descent, SGD and LBFGS, and you can see the minimum iteration you can set. I'm choosing the default values, and again everything is 100%. I'm choosing maybe ROC curve for this, and it is perfect. And I'm choosing cumulative gains curve. It is not very perfect, but cumulative gains of 0.62 is not bad. It is reaching up to maybe around 1 when you take percentage of samples. Okay, so gain is reaching 1 when 100% of the sample is considered, and we will consider obviously 300% of the train sample in our analysis. Okay, so this was about a simple data set, though it was looking simple, but it has multi-class classification. Now we will take one practical real data set, that is the diabetes data set. But the purpose of showing this is that whenever, first of all, when a client asks, what do you do as a data scientist? Then you just have to say that provide me your data. That's all. The rest of the things we do is like this. You can give that this video, and if they are a little bit curious, they are not even technically qualified, then they will immediately understand that they will just give this data and they will get the final model and the report. But in between, how much effort is gone trying various algorithms, trying setting hyperparameters for each various algorithm, and plotting the curves so that the model is not just tested on the basis of accuracy and precision, but the model is tested on the basis of many other parameter, like what is the lift for class-wise lift, what is the uh, precision recall curve, ROC curve, and calibration plot, and many other things. So, as a data science student, also, if somebody is watching this, then unless and until you are clear about all these aspects, then you should not consider that you know classification. Okay. Now, let me upload another data file, that is diabetes. It is a real life data, and previous data is maintained. So this was that sepal length and all that. That was for iris data set. The usefulness of that is that here these are two totally different data sets, so there is no point of comparing. But data set is maintained previous. That is because you can do some feature engineering in same data set and upload again. Then again some feature engineering and same data set and upload again. Then all your results, statistical summary and everything is maintained. You just have to maybe copy paste from here, or you can even provide some uh, automated way that these results are presented to the client in accurate manner. Okay. Now you can see our data set has a total 9 columns. Pregnancies, how many pregnancies the patient had, glucose level, blood pressure level, skin thickness, insulin, BMI, value of diabetes pedigree function, and age, and this is the response variable outcome. So that means whether the person is likely to develop, likely to have diabetes or not, based on how many pregnancies the person had. In case of course, female client, this data set is PIMA India the female data set. That's why glucose level, blood pressure level, skin thickness, insulin, BMI is based on these many features, 8 features. You can easily predict the outcome whether the person will be diabetic or non-diabetic. So this is a binary classification. So this is a outcome variable only you have to specify. So outcome variable here is named outcome only. So outcome. One means the person is diabetic and two means the person is not diabetic. Now random forest, and you can see estimators are 100, max depth 10, minimum sample split is 2, and minimum sample lift is 1. And now I click train and evaluate. So here is my random forest, and its accuracy is now 75.75%. And this is the class-wise precision and recall. So you can see that for a practical data set, it is not 100%. But even if you can predict diabetes with a 75% accuracy, then that is good enough. And there are 110 ways of still improving your model. So I may try to increase the max depth to 50, and I may try to increase maybe minimum sample leaf to 2, just as a trying. So 0.7575 was there. Now let us see what I get. I get 0.7532. So that means it is worsening actually. So I may keep this one only and try again. So this time I get 7489. So even this is not getting perfect. Okay. So maybe max depth of around 20, and then 744. So all these are, compared to that, the best random forest is here. But now you can see the usefulness or versatility of this app, that for a given chosen algorithm, it can allow the hyperparameter tuning, and once a best algorithm is chosen, then even in that best algorithm, the best hyperparameters you have to choose. That is what we do. This is actually what we do by that grid search CV or other cross validation techniques. But if you want to show the demo of what you are doing as a data scientist to either some students or maybe your client, then you can show this. Now I plot the ROC curve, and you can see ROC curve is not very good, even 75% accuracy, but area under ROC curve is only 0.19. Precision recall curve is also not that good, and explained variance seems okay, because as you take 0 to 7 features, these are 0 to 7 features, then explained variance actually goes on increasing. Okay, explained variance goes on increasing, and if you take all features, then explained variance is 1. So sometimes you have heard that a simple model is better. Yes, simple model is better, but as compared to feature removal, feature engineering is always better. That is, feature removal means you are always causing some loss of data, and it might affect the accuracy, or it might affect the ability, generalizability. But feature engineering, in which you try to reduce the columns in your data by combining two columns, or something or some other thing, that is always better. Okay. Now random forest, I just take XGBoost and I will pause. Okay. So XGBoost, and here best random forest at 0.7575. Now let us see what XGBoost gives. XGBoost is giving 0.74 something. So it is not that good. And if I increase the learning rate, maybe actually increasing, maybe I increase the depth and I reduce the learning rate to zero point zero 0.05, then I do this train and evaluate. So then this time it is 0.7445. So this way you can try n number of combinations and permutations, and you can tune your algorithm quickly. Now, can you understand the importance of this? That whenever a client comes with a new data set, new business problem, and once you classify that this business problem is actually, from the data science point of view, it is just a classification problem. For example, whether the client will default on the loan or not, yes or no, binary classification. Whether this client is likely to, or whether this transaction is fraudulent transaction or not, again, yes or no, binary classification. Then whether this customer will churn or not, again binary classification. Whether this employee will churn or not in HR analytics. Then as soon as the data comes to you, features may keep on changing, But once you develop such a generic classifier, then you can quickly iterate through a large number of algorithms, and you can quickly iterate large number of hyperparameters here, and you can quickly evaluate both results by accuracy F1 score, precision recall, and by various kinds of curve. Okay, thank you.